Hi everyone, today we are going to demonstrate the second experiment, which is absorption of light. So in this experiment, first we will see the assembly of our optical system. So here it is our helium neon laser, and then we have density filter, and then density filter is just to minimize the intensity of light, and we have a chopping wheel that check the effect of ambient light. And here we have a two mirror aligned together to give a optical path which will interact with our sample. And here we have a stirrer in which is placed beneath the rectangular cell in which our sample will be placed. And there is a small bead which is a kind of a magnetic stirrer which rotates and properly mix the water, which is our sample. And then we have this detector which connects to the computer and show the reading. As I told you earlier, in this experiment we will check the absorption of light. So I already explained you the optical assembly, and now in this experiment we will check the absorption of sample. Sample consists of 3 dyes. First we will check the absorption without any dye, just the plain water as a sample, in which the light is not attenuated by any dye. So first we will check the unattenuated light with the just water, and then we will add dyes in it. We have 3 dyes, and depending on the wavelength interacts with that sample color, the effect of light keep on decreasing on the absorption behavior. So we will see the transmission of light like under water, which will be unattenuated light. So as you can see, our optical path delivers the light and it passes through the water and reach out to the detector, and we have a signal on the software. Here we just measure the transmission of light in water and check the transmission on the software. Now we will try to add the dyes, and because of this dye the concentration of sample changed, and because of this change in concentration of the sample, we reflect the different value in the transmission of light. So first we will add our dye 1. Now you can clearly see the concentration of this sample changed because of this dye. Now we'll try to dilute this sample, and by diluting this we will see the change in transmission. Now we'll repeat the same protocol by using our second dye. As you can see, because of this dye, the concentration of sample gets changed, and that will reflect on the transmission of light. Our third dye, which is a red dye, and we will check how it affects the transmission.
So this is helium neon laser source. This is filter wheel. We can adjust the filter according to our requirement. This is chopper wheel. The purpose of chopper wheel is to reduce the background light effect, and the light will pass through the chopper and hit to the first mirror, and then it will reflect to the second mirror, which will go to the water bath, and then from the water bath it will fall on the photo detector, and from the photo detector, which is attached to the computer, we get the signals according to the change in concentration of liquid. So this is the whole setup. We align that sample with the reflection from the second mirror, and this is the alignment of laser, chopper wheel, M1, which is mirror 1, M2, which is mirror 2, and then the computer software.
By the help of Beard-Lambert's law, we will try to check the transmission intensity of the light with respect to the concentration of the sample, and we will try to plot it as a graph, and we will see how much the concentration of a sample affects the transmission of the light.